Well, hello again. This is a recording of the little mini lecture that I did during class. That was a follow up to my first mini lecture on interference. So there's actually a second one. And the next page of your notes, you'll see it says interference continued. 2-point sources. Okay. So there's a picture on there that I'll explain, but I want to show you where that picture came from first. And so let me bring this in. So I've described to you what a ripple tank is, and I'll show you as I move it into position. Here we go. So a ripple tank is like a little pool of water, and as you make waves in the water by like poking your finger in it or moving the water around, it will make waves. So this is a simulation of a ripple tank, and the way I have it set up here is I have imagine two fingers that are bobbing up and down next to each other in a ripple tank, and that's what those two little sources of waves are in the middle. So if we had just one source, and let me just change it to one source. This is a little easier to kind of imagine. We just get circular waves that go out like that, right? And we see crests and troughs. They show up here as light and dark areas, kind of a light blue and a dark area. But when we bring in the second source, just maybe move them up so they're centered. And then something kind of interesting happens. All right, so I'm going to freeze it here. And this is the picture that's actually on your page. You can notice, and I'm going to move my mouse here. Do you see some area here where it's kind of shaded and cloudy? You don't see the bright and dark areas like you do in other places. There's also one here, here, and here. So on my picture, on my screen, what you're looking at, there are 8 of these. There's 4 on each side. Now on the picture on your page, there are actually, there are 8 as well. So this actually is very close to what you see on the page. So what are we looking at here? Well, I want to remind you that if we have two sources of waves, at some point, some of these waves are going to meet at the same point on the medium at the same time. And what we saw in the previous video was, we call that interference. If we have two crests or two troughs interfering, we're going to make a really big crest or a really big trough. But there's some areas where we have the crest from one meeting the trough of the other. And if they are the same size wave, then we will get complete destructive interference, and there will be no wave motion at all. And that's what these shaded areas here are. That's where a crest from one of these sources is meeting a trough from the other. Okay, a whole line of them kind of radiating out from the middle. And then in between them, you can see, like where I'm moving my mouse right now, very bright and dark lines, okay? So let's go to your page of your notes, and we'll figure out how to write this. There we go. We'll zoom out just a hair so you can see it a little bit better. Okay, so if you describe this, this is two sources of circular waves that we're looking at here. And on the left side of your page, I kind of described what the bright and dark areas are about. I call those like the live spots with very large waves. Big crests, big troughs right there. And I pointed to the other ones. There are 8 of these. So the top and the bottom, and then 3 on each side, where it's very bright, very dark in between. Okay, so those are all points of where we have constructive interference. But on the other side, I've pointed to the sort of grayed out areas, what I call the dead spots, where you have no wave at all. Not because there's not waves, it's actually because there's 2 waves simultaneously at the same spot. And because a crest and a trough are meeting right there, that's where we get momentarily complete destructive interference. And with 2 wave sources, as long as they have the same frequency and they don't move around, these will always form these sort of radiating lines, okay? I'm going to show you another simulation of what it would be like if you were floating on a little boat, let's say, in this pool, the ripple tank, how it could be very different for you than the person in the boat right next to you. All right, this is one of my other favorite ways to kind of see this. So you're looking at a 3D view of the same thing. We've just got 2 little bobbers here in white that are in sync with each other, same frequency, they're not moving or anything like that. they're just bobbing up and down, making these surface waves, which might be kind of hard to see here. But I want to point your attention to the little orange and the little purple ball out here that are just sitting in the little ripple tank. So one of them is moving quite a bit, because if you look at where one of them is, right in the middle, that's one of those areas of very big constructive interference. But just off to the side is the little purple one. Now let's look at it from a different perspective. There we go. So here, again, here's the white things making the waves on either side. Here's the orange one right in the middle. You see how much it's going up and down? And here's the purple one with no motion at all, even though it's right next to this one. And that's because the purple one is on one of these lines where we get complete destructive interference. And if you were in a boat, you would be perfectly still, while the boat just over here in the middle of the pattern would be rising and falling violently almost. Okay? So just another little view that might be helpful for you to kind of see that. And that can explain this sort of two-dimensional interference pattern that's kind of neat. All right, that's all I want you to see there. Make sure if you need to go back and write down any of those things you had in your notes that you have them complete. And then that'll be it for now. Thanks.